Today we discuss on important topics related to multiplicity of roots. Okay, we start from one definition now. We write here definition. Okay, let K be a field and Px be an irreducible polynomial. In Kx, okay, of degree n. Then Px is called. Then Px is called separable. Okay, separable if it has n distinct root. It has n distinct roots in a splitting field. Roots in a splitting field. Okay, in a splitting field is of Px. Okay, over K. That means Px is separable if it has n distinct root in a splitting field S of Px over K. Okay, that means Px is irreducible in K and obviously split or have n distinct root in S. Okay, then this one is separable. Okay, otherwise what happen? Px is called inseparable. Px is called inseparable. Okay, over K. That means one polynomial is separable and inseparable when we also understand this one. Okay, now we're going to discuss another definition. Okay, we write here definition. Another definition, let f extension of K is a field extension. Okay, is a field extension and C be an element of F. Okay, if extension of K be a field is a field extension and C be an element of F. Okay, which is algebraic over K. Which is algebraic over K. Okay, then what happened? Then C is called separable. Then C is called separable. Okay, C is called separable over K if its minimal polynomial over K. If its minimal polynomial over K, okay, is separable. then f extension of k be a field extension and c be an element of f which is algebraic over k. Okay, then c is called separable over k if its minimal polynomial over k is separable. Okay, now otherwise c is called inseparable. Otherwise c is called inseparable. Okay, not a problem at all. Inseparable over k. Okay, then in this way we also discuss, that means one element of this extension is separable or not inseparable. Okay, so now we discussion one theorem related to that topics. Okay, we write just theorem statement of this theorem now. Okay, we write here theorem. Okay, let k be a field, let k be a field. Okay, and fx belongs to kx and fx not equal to 0. Let a be a root of fx. Let a be a root of fx. Okay, let a be a root of fx in some extension field. In some extension field f of k, f of k, then a is a multiple root, then a is a multiple root of fx. Okay, if and only if and only if what, if dash a equal to 0. Okay, if dash a equal to 0. So that means fx belongs to kx, fx not equal to 0, a be a root of fx in some extension field f of k, then a is a multiple root of fx if and only if dash a equal to 0. We have to prove this theorem now. Okay, now we erase that portion, lower portion, and going to further discussion of that. Okay, now we write here proof. Okay, suppose a is a multiple root of fx. Suppose a is a multiple root of fx. Okay, then what happened? Then x difference is square. Okay, divides fx. Not a problem at all. Okay, that means x difference a divides fx but multiple root, then x difference a square divide fx at least square. Okay, hence what happened, hence fx equal to x difference a square, here gx. Okay, for some gx belongs to this fx. Okay, not a problem at all. Now if dash x equal to what? Now if dash x equal to, here x difference a, okay, square g dash x, okay, plus here 2x difference a gx, not a problem at all. I think this one equal to f dash x. Okay, now f dash a equal to 0 gives, f dash a equal to, sorry, equal to 0 gives what? We write here f dash a, then this one all are 0. Okay, not a problem at all. Sorry, then this one, that means f dash a equal to 0, we have to prove this one. Okay, now so this one equal to 0, that means f dash a equal to, we put a here and then we, that means evaluate this value equal to 0. So we first, that means take this one, a is a multiple root, then this one happen. Okay, now conversely, now conversely, okay, that means we let, or suppose this one, suppose f dash a equal to 0. Okay, then what happen, then we write, then degree of fx, okay, what happened, greater than equal to 2, not a problem at all. Then by division algorithm, okay, we use here division algorithm. By division algorithm, here fx equal to x difference a whole square, okay, qx plus hx. Okay, for some qx and hx belongs to, for some qx hx belongs to this fx. Okay, not a problem at all. Then what happened, then we also see that this one, that means either hx equal to 0 or h degree of hx less than 1. So it is our portion now. Now we write here in this way, where either hx equal to 0 or degree of hx is then equal to 1. Not a problem at all. Now suppose hx equal, okay, suppose hx not equal to 0, Then what happened? Since fa equal to 0, ha equal to 0, okay, that means if fa equal to 0, then ha equal to 0, not a problem at all, okay. Now then degree of hx equal to 1, not a problem at all. If hx not equal to 0, then what happens? If a equal to 0 and ha equal to 0, then degree of hx equal to 1. A is a some root, okay, not a problem at all. Then what happened? And obviously here, right, and a is a root of hx, okay. So hence hx equal to some constant multiplied by this x difference a, okay. Here b not equal to 0 belongs to k, okay. Then what happened here? Then we write this implies that, okay, this implies that what? Fx equal to this x difference is square, okay, qx plus here x difference ab equal to what? Equal to x difference a multiplied by this, okay, equal to x difference a multiplied by some mx, okay, not a problem at all. So we write here mx equal to what? Mx equal to x difference a qx plus b, okay, not a problem at all. Now also that means erase that portion. Now what happened here? That means we also get this fx, okay. Now we also use f dash a equal to 0, okay. That means we evaluate first f dash x. F dash x equal to what? 2x difference a qx plus here x minus x difference is whole square q dash x, okay. Here b. So f dash a equal to 0 gives what? Here put a, then b equal to 0, not a problem at all. So what we get? We get a contradiction. That means what contradiction? That means hx equal to 0. We also will here suppose hx not equal to 0, and we also that means find hx equal to b multiplied x difference a, and here b equal to 0, then hx equal to 0. So one contradiction occur here. Hence what happened? Hence we write in this way, hence hx equal to 0, okay. And so what we get? So fx equal to, okay, so fx equal to x difference a whole square qx, okay, not a problem at all. Then this one a is a multiple root, then we find what? A is a multiple root of fx, okay. That means we prove this one easily, I think, okay, not a problem at all. All are understand this one easily. That means what happened here? some a be a root of fx, then a is a multiple root of fx if and only if f dash a equal to 0. I think this theorem are that means easily understand by all, and all are, I think, that means step by step clearly done this one. Okay, so today I stop here. If you get this type of video, please subscribe and follow my channel and see this video regularly and click on like options. I think this one is sufficient for today. Now stop here.